Hi students, in today's video we're going to learn how to find the length of a line segment in this chapter, coordinate geometry. Right, let's look at this question. There are two parts to this question, part A and B. Part A, we are given 2 points where they are labeled as point A and B, and part B, you're given another 2 points labeled as C and D. Right, to start off, let's do a recap. Right, what's the recap? The recap is to write down the formula, okay, for finding a line segment. Supposing if we have 2 points, right, the first point is A, and I'm going to label it as the x coordinate as x1, y1, and then point B, the x coordinate and the y coordinate as x2, y2, right? So the length of the line segment joining these 2 points, what it means is that you have 2 points here. Right, so the length will refer to here. Okay, so to find that length or the distance, you can also call it the distance, right? The formula would be, all right, so this formula is actually based on Pythagoras theorem, right? You can derive this formula using Pythagoras theorem, but in this video, we are just more concerned about how we can actually apply this formula, right? So let's look at part A. So what's the first step that you need to do? It's very important. A lot of students actually neglect doing this part. But doing this part is very important, and that is to label your points. Right, label the point as x1, y1 and x2, y2. So there are 2 points there. So you can label your point A as that means you let the x coordinate of point A to be x1, let the y coordinates of point A to be y1, and for point B, let the x coordinate be labeled as x2, and the y coordinates of point B as y2. Okay, then the next step is let's write down the formula. All right, so we can just substitute in, right? So how do you substitute in? So you refer to your labeling again, your x2 here. This will be the value 7, and then your x1 will be the value 3. So if you look at your y coordinates, your y2 will be the number 2, and then your y1 will be also the number 2. So that's how we substitute to get this value here. And this you can just easily use a calculator to evaluate. Just make sure that you press the square root sign on the calculator, bracket 7 minus 3 close bracket squared plus open bracket again 2 minus 2 close bracket and then square. And then you get 4 units as the answer. Right, so there's a question that I'd like you to think about. The question is that can I label the points as for point A, instead of labeling as x1, y1, can I label it as x2, y2? And for point B, label it as x1, y1 instead. That means I do the reverse as what I've done earlier. So the answer is yes. Yes, you can. Why? Because you still get the same answer. Okay, you will still get the same answer. Right, so let's look at part B. So for part B, yes, do not neglect the steps of labeling the point. So I'm going to label point C as x2, y2, point D as x1, y1. And then let's write down the formula. Right, so you substitute in the values. So the values for x2 will be 4, x1 will be 4 also. The values for y2 will be 5, and the values for y1 to be negative 3. Okay, and use your calculator to evaluate, get 8 units. So again, I have a questions for you. So what is it that you have to take note when you're substituting the values of x and y into the formula? Yes, why do you think I highlight bracket negative 3? Yes, this is something you have to take note. All right, if you have a negative value, right, it is very important that you bracket it. Because if you don't bracket it, okay, if you don't bracket a -3, you may end up getting something like this. And then this is not the correct answer. All right, so it's very important that if you have a negative value, okay, it's very, very important that you bracket it. So in this case here, there will be two brackets here, okay, a smaller one inside and then a bigger one outside. All right, so let's look at these questions. So you're given a triangle, and this triangle had 3 points, 3 vertices, and you asked to show that triangle ABC is an isosceles triangle. Right, so before we do these questions, let's do a recap on what is an isosceles triangle. So an isosceles triangle is one where you have two of the sides having the same length. So it can be this way, can be this. Right, so the hint given there is to find the length of all the 3 sides. And then we show that 2 of them have the same value. And that proves that it's an isosceles triangle. So before we do this question, I think it's good that we do a sketch of the diagram. You don't need to be very accurate. So let's have this point as -1, -2. And then we have a point B that it's 1, 8. And a point C that is -5. So I need to extend this longer. So -5, 4. So if we join these 3 sides, join these 3 points, you can see that we have a triangle ABC, right? And we need to show that this is an isosceles triangle. All right, so let's find distance for all these 3 lines. Let's start off by finding the distance for AB. Right, so let's do the labeling again. You can label this as x1, y1. This is x2, y2. Okay, let's write down the formula. So you have to remember the formula. It's quite easy to remember. There's a square root there, and then there's a bracket. x1, x2 minus x1 squared plus y2 minus y1 squared. All right, so there's another question that you may want to ask. That can I, instead of using x2, I just use x1 first? Well, you can, but if you want to use x1 minus x2, then for the y coordinates, you will have to use y1 minus y2 squared. Okay, you have to follow the order. That means if you start off with x1 minus x2, then for the y coordinate, it has to be y1 minus y2. If you start off with x2 minus x1, then for the y coordinate, you have to start with y2. So this is something you have to take note. Otherwise, you won't get the correct answer. Okay, so let's do the substitution. So the values for x2 will be 1 minus value for x1 is -1. So as we mentioned earlier on, if it's -1, you make sure you bracket it. Then y2 is 8 minus, again, bracket -2. Right, and this you can just use your calculator to work this out. That will give you square root bracket 1 minus bracket -1 bracket again square plus bracket 8 minus bracket -2 close square. Right, and you will get you can express your answer to 3 significant figure. That will be 10.2 units. All right, so let's do the same for BC. So in this case here, I would label, I've already labeled point B as x2, y2. So I'm just going to label this as x1, y1. Okay, so that's fine, BC. Right, let's write down the formula. Right, so I have x2, which is 1 minus bracket negative 5 close bracket again squared, plus y2, which is 8 minus 4 close bracket squared. All right, then you can use your calculator to work it out. Right, you get 7.21. Expressed to, it's not an exact value, so you just put it to 2 decimal places, 7.21 units. All right, so let's go on to find the length for AC. All right, so if you look at AC, actually both points are being labeled x1, y1. So what you can do is you can change this, right, to x2, y2 instead. Or you can change your point A to x2, y2, okay, depending on your preference. So let's do AC. All right, similarly, let's write down the formula. And I would have x2, which is negative 5, minus bracket negative 1, close bracket again, squared. So this part here, you have to be very careful, okay? It's not difficult to find the length of 2 points, but the substitution, you have to be very careful. So if you see again, your y1 is a negative value, so you need to bracket it, bracket negative 2, close bracket, then square. And then you can just go ahead and use a calculator to work it out. So when you use a calculator, also be very careful. Okay, press the square root sign first. Press bracket negative 5, followed by minus bracket minus 1, close bracket. And then close again, square it. Then plus open bracket 4 minus open bracket negative 2, close, square. And you get 7.21. Right, so we see that there are two line segments, they have the same length, BC and AC. Right, so we can conclude, we can answer the questions with a concluding statement. So what's the concluding statement? So we can say that since BC, that means the length of BC is equals to the length of AC, right, which is equals to 7.21 units. All right, that means your BC is equals to your AC, right? So we can say that therefore triangle ABC is an isosceles triangle. Okay, so this is how you do it. Right, let's look at questions 5. If you look at questions 5, there are 2 points. You're given 2 points. Point P. Point P, we know the x and the y coordinates. The x coordinate is negative 3, y coordinate is 2. But for point Q, you see that you're only given the x coordinate. The y coordinate is an unknown, okay, indicated by the variable, by the letter k, right? And you're asked to find the possible values of k. Right. So there are two informations here, okay? If you were to do a sketch of how the 2 points looks alike, point P is negative 3, 2, so it would be, let's say, roughly here. and you have a point Q which is 1k. So you don't know where k is, but you know the x coordinate is 1. So it could be somewhere here. And you are told that when you join a line from P to Q, you are told that the line segment, that means this guy, the distance from P to Q is 5 units. All right. So if you're talking about distance, so distance, what does distance refer to? Remind you of? Yes, distance will remind you of length of a line segment, right? And what does length of a line segment reminds you of? Yes, the formula, of course, the formula, right? The formula, which is bracket x2 minus x1 squared plus y2 minus y1 squared. Okay, the formula. Right, so this is exactly what we're going to do. We're going to find the distance for PQ. So first step, very important, label your point. Okay, and then write down the formula. I cannot emphasize the importance of labeling the points, because sometimes if you don't label the points, you may substitute in wrongly. So it's a good habit to actually label the points. All right, so now we can do the substitution. So x2 will be 1 minus the values for x2 is 1. The values for x1 is a negative 3, so make sure you bracket it. So bracket, negative bracket, negative bracket, negative 3, close, close, square, plus open bracket again. Y2 is the unknown, k, minus away y1, it's 2, close the bracket. All right, so if you look at what you have here, the only thing you can simplify, the only thing you can use your calculator to simplify will be this they have underlined for you. All right, so this one you can just use a calculator and make sure you do it properly. So it's bracket 1 minus open bracket negative 3, close the bracket, square, and that gives you 16. So this one here, where you have a unknown k, obviously you can't use a calculator. You don't know what k represents. K can be any value. So you can't use a calculator to, you don't know what value to punch in, you know what I mean? So you just leave it alone as bracket k minus 2 squared. Right. So go back and look at the questions again. There's another piece of information that you've been told. Yes, the information that you've been told is this very important information here, where they say that distance between these 2 points here is 5 units. Right, so you're given PQ is equals to 5 units. Right, so since we're talking about the same thing, right, PQ equals to this guy, PQ equals to 5 units. And since PQ is equals to PQ, what's the conclusions that you can make? Since PQ is equals to PQ, what kind of conclusions can you make? Yes, these two guys will be the same, right? Your square root 16 plus bracket k minus 2 squared will be equals to 5. Right, so the next thing is that I need to solve it. So to solve it means to find the values of k, right? So how do I get rid of this square root? Right, so I give you an example. If you have a square root x equals to 2, what do you think is the possible value of x? That means what is the value I can substitute for x? So then when I square root it, I get 2. Is it square root 9? Is it square root 25? What should it be? Yes, it's square root 4. Square root 4 will give me 2. So the values for x will be 4. And how did I get 4? If you look at this, how do you think I can get 4 from 2? Yes, that's by squaring 2, right? When I square 2, I get 4, right? So if you have square root x equals to 2, to get x, you just square your 2. Okay, so this is exactly what we're going to do. To find the values for this guy here, I just need to square my 5. And 5 squared will give me 25. Then the next thing is that I need to get rid of my 16, so I might subtract 16 on both sides. So 25 minus 16 will give you 9. Okay. Now, so if you have a squared equals to 9, what are the possible values for a? Can be 3, right? Because 3 times 3 gives you 9. It can also be negative 3, because negative 3 times negative 3, right? Negative times negative gives you positive. 3 times 3 gives you 9. So if you have an equations where you're supposed to solve and this power here is an even number, you will get 2 values, one positive, one negative. And how do you get 3? To get 3 means you square root 9. You see, you do the opposite. Just now when I have a square root here, to find the values, I square 5. Now when I have a square here, right, to remove the square, I square root 9. You get it? We always do the opposite action. So square root 9 will be give me 3. And like what we mentioned here in this example here, there are 2 possible answers. So one is positive 3 and one is negative 3. So I would get k equals to 5 or k equals to negative 3 plus 2 gives you negative 1. Okay. So how would the point looks like? So that means your q can be 1, 5, or your q can be here, which is 1 but a negative 1. So that's why there are 2 possible values of k.